Geometry, Unit 5, Section 3, Rectangles. So the first video in this series is about a trapezoid, and trapezoids have at least one pair of parallel sides, and then the last video was on parallelograms, which have exactly two pairs of opposite sides parallel. A rectangle is a parallelogram, and so that means that it has both pairs of opposite sides parallel. And it also has all the properties of a parallelogram. So it has opposite sides parallel. It has opposite sides congruent. It has opposite angles congruent. It has opposite angles congruent. I already said that. It has consecutive angles, supplementary. It has diagonals that bisect. It has all of these properties of a parallelogram, plus a few of its own. Now, in a parallelogram, as I said, I think twice, opposite angles are congruent. But for a rectangle, we actually change that to all angles are congruent. And the reason all the angles are congruent is because the sides are perpendicular. And perpendicular sides form right angles, as we know. So, since they're all right angles, they are all congruent. All the angles are 90 because all this adjacent and consecutive sides are perpendicular. So not just opposite side, excuse me, I really having trouble speaking in this video. Not just opposite angles congruent, but all angles congruent in a rectangle because the sides are perpendicular. And then for diagonals, we still have diagonals bisect each other because it's a parallelogram. So the diagonals are still cutting each other in half, but now because it's a rectangle, diagonals are congruent. And that's really an important one because in a parallelogram, the diagonals only bisect, but in a rectangle, they are congruent. And in the next video, when we get to a rhombus, they're perpendicular. Not congruent, perpendicular. And when you get to the square, the diagonals are perpendicular and congruent. So it gets a little confusing at first, and you'll be getting a, kind of a flow chart of all these different properties and how they relate to each other. So you really know this stuff, but it's really half the battle with parallelograms is remembering the properties. And for a rectangle, you guys have known rectangles for a long time from previous grades and things like that. And so I think you know the sides are perpendicular and you know the parallel and all that stuff. You know they're right angles. Maybe what you don't know is that the diagonals are congruent. So make sure you remember that. All right, let's see it in a proof. First, there's a couple of edits I want to make on this. They want to prove AE is congruent to BF. That can be done, but it's going to take a while. And it's going to take some subtraction. So I'm actually going to cut that, and let's make it AF is congruent to BE. And we can do this with CPCTC. So that's what we want to prove. AF is congruent to BF. And so if I prove this triangle here is congruent to this triangle here, then their corresponding parts will be congruent. So that's how we're going to go about this. So ABCD is a rectangle. That's our first given. And just like the parallelogram and a lot of this chapter, the difficult thing about the givens is I don't know which property of the rectangle I'm going to be using. And you got to think about all the properties of parallelograms, all the properties of a rectangle. So let's look at them. Does opposite sides congruent help us out? Yes, it does. And remember, opposite sides congruent, that's not a rectangle property, it's a parallelogram property. But since a rectangle is a parallelogram, it can be used. And that's our first statement here. And we can say opposite sides of a rectangle are congruent. You wouldn't be wrong if you said opposite sides of a parallelogram are congruent too, because a rectangle is a parallelogram. How about opposite angles? Well, remember, for a rectangle, it's not just opposite angles, it's all angles. So angle A and angle B here, they're not opposite angles, but because it's a rectangle, they don't need to be. All four angles are right angles, so all four angles are congruent. So we can say that all angles of a rectangle are congruent. That is a rectangle property. That's our first time we're seeing the property that all four angles of the quadrilateral are congruent. So all those angles are congruent. And then you were given another angle congruency here. And so that actually is enough to prove your triangles right away. Pretty quick one here with angle side angle, congruent to angle, side angle. So what didn't we use from the rectangle? Well, we didn't use anything about parallel. There is no alternate interior or corresponding mentioned. We did not use the diagonals bisect each other, diagonals congruent. There's no diagonals drawn here. Remember, EC is not a diagonal. It'd have to be AC to be considered a diagonal. So you have to kind of figure out which properties are going to be used, and every proof is different. Next time we do a proof in class where we're given a rectangle, we might not use opposite sides or all angles. It might be focused on the diagonals instead. So that's what makes it a little challenging, is you got to kind of take a look at the picture and figure out which properties would be useful for you. But then we wanted to prove AF and BE. But again, this is from my old one, so AF is congruent to BE with CP/CTC. And so that's it for that one. So this is basically it. Like I said, if you can remember the properties of the rectangle, the special properties, all angles congruent, perpendicular sides, diagonals congruent, and then all of the properties from the parallelogram, you have to remember they're all there too. If you can remember all the properties, that's really what makes these questions easy. And the fact that we have perpendicular sides here means an algebra question could involve a right triangle, maybe Pythagorean theorem, that type of stuff could come up. So we watch out for that, of course. And so our next video is going to be focused on the rhombus. And the rhombus is different than a rectangle. It's also a parallelogram, but it has its own special properties, like the rectangle has its own special properties. And then we'll wrap up this chapter by talking about the square, which is really take all the properties from the rectangle, all the properties of a rhombus, and put them together. Let's not get too far ahead of ourselves, and we'll work on rectangle properties in class later. See ya.